Hey there, geometry. We're going to take kind of a momentous step. One of the big things you're going to do in geometry this year is to prove things. We've been working our way up to it in this chapter, but now you're going to actually learn how to write a proof. There's some other words that you need to know along with this. One of them would be a postulate, or sometimes we'll call those axioms. And it just simply means the same thing. A postulate or an axiom is a statement that is just accepted as true. We don't really have to prove it. It's just accepted that way. They have a number of these in your book. Let's see. It's on the very first page. It's on page 141. And they give you 7 of those. You can look at those. But an example would be something like, through any 2 points, there's exactly one line that can go through those. And if you think about these, they're not brain busters. They're things like, usually you hear them and you go, oh yeah, of course. If it's something like that you just say, of course, that's a postulate or an axiom. Things that are harder than that, though, you're going to actually have to prove that they're true. They're not just going to be accepted. And when we prove these things, we're going to be using, again, deductive reasoning. There will be some generalized statement, and what you have to do is you have to go back, and then from that generalized statement, you're going to have to link together a chain of statements until you get to where you're going. That's a formal proof. Usually what they'll do is they'll have it in terms of, like, let me give you an example. I'll do a very simple algebraic proof for you because you already know geometry. At least I hope you do. So here would be an example of an algebraic proof. Let's say they gave you something like x plus 1 equals 3. They would say if x plus 1 equals 3, then x equals 2. Hope that's not too hard for you. You see it's stated in the form of a if-then statement, a conditional. So what you're going to do whenever you write a proof is you're going to say, first thing you're going to say is you're going to tell what you're given. And I know this is a little bit weird the first time you do it. It will get very easy to you, very normal. So what's the thing you're given? You're given this. You're given x plus 1 equals 3. You don't have to do anything. You don't have to prove that. That's what you're given. But now what you have to do is you have to go back and you have to use smaller statements that you're going to link together to work up to then x equals 2. When we did this in algebra, we didn't call it proving something. What we did, we called it solving the equation. But if you think about it, that's exactly what we're doing every time. So given x plus 1 equals 3, then what you would do is you would say something like, okay, from my laws of algebra that I know that I can do x plus 1. I can take this side and I can subtract 1 from that side. And I can take the right side and I can subtract 1 from that side. If they're equal before, they're going to be equal after. And then what you do is you tell how you know that. In this case, I know that because of the subtraction property of equality. I'm not going to write all that because it takes forever for me. Let me make sure that you can follow along with this. After this step, I can see that I can combine those two and I can get x plus 0, and 3 minus 1 is going to give you 2. So basically what I did was I took these two numbers, I added them together, and I substituted in, instead of this, I can substitute in something that's similar. Instead of that, I can substitute in something that means the same thing. That is called the substitution property of equality. And lastly, if I have x plus 0 equals 2, by the you probably remember the additive identity property? Then x equals 2. So adding 0 to something doesn't essentially change it. It's the same thing. It's just going to be x. So that would be the additive identity property. And so do you see, I've started with something, and by a series of steps, I've proven what I wanted to prove. Okay, we're not going to be doing really algebraic proofs. We're going to be mostly doing geometric proofs. So why don't we try a simple one of those? Let me reset so you can see. A geometric proof. And I have to pick a very simple one because you don't know very much geometry. Let's say that I had a line segment. This is P, this is Q, and this is R. And I say that I'm going to tell you that, so given Q is the midpoint of line segment PR. Oops. So that's what I'm giving you. And here's what I want you to prove. So if Q is the midpoint, then the distance from P to Q, or the line segment PQ, is congruent to QR. That's where I'm going. I can't go from this to that in just one step, but it's not going to be very hard. So given Q is the midpoint of PR, then my next step is, I know that the distance from P to Q is the same as the distance from Q to R. And how do I know that? Because that's what it means that it's a midpoint. Midpoint means exactly in the middle. And then simply one more step. I therefore know that line segment PQ is congruent to line segment QR, because that is what congruent means. Congruent things line segment PQ is congruent to line segment QR because that's the definition of congruence. So there's a very simple geometric proof. We're going to work on more of these. They're going to get more difficult. There's one last word I want you to know, and that is what a theorem is. After you have proven something, then we call it a theorem. And oftentimes you're going to use that theorem and you're going to go on to prove more things. It's like, building a house. You're building a foundation, you build on that, you build on top of that, and you get higher and higher and higher. The first theorem they give you is the one that we just proved. They're going to call it Theorem 2.1, and it's on the middle of page 145. So Theorem 2.1. And it simply says that if M is the midpoint, if you have A and B and M, sorry, let me get the book out of the way here. It says if M is the midpoint, then AM is congruent to MB. If M is the midpoint. You will need to keep track of these theorems. You can't just listen to them, have them go in one ear out of the other, because you're going to need these to prove other things. It's very simple, but I want you to know where it's found, and I want you to know what the word means, okay? All right, I think that's all for this section. See ya.